Good morning, dear students. In the last lecture, we have studied about the electrolytic refining of copper as well as the passage of electricity through the sodium chloride aqueous solution. Now, we want to understand further the electrolysis of molten NaCl. So, if the electricity if the electricity is or the DC current is passed through the molten NaCl, that is NaCl liquid. At anode we get chlorine gas and at cathode we get sodium metal deposited on the electrode. You can see here NaCl is liquid, which is simply turned into Na plus and Cl minus, and when we pass the electricity, that is the DC current, at cathode we get sodium solid which is deposited. At an anode we get the chlorine gas produced. This is how we really understand the uh, difference between the electrolysis of aqueous sodium chloride solution and molten sodium chloride melt. Here, if we really understand, we realize that if Na plus and Cl minus ions are present, sodium Na metal and chlorine gas are produced. So it simply means that if OH minus ions and H minus ions are not present, we get NaCl to be converted into sodium metal and chlorine gas. But if we take aqueous solution of NaCl, then we have Na plus and H plus, we have Cl minus and OH minus ions, and due to this there will be competition between the Na plus and H plus, between the Cl minus and OH minus, and we shall see that less reactive H plus is reduced and more reactive Cl minus ions are oxidized. So this is how we can understand that we realize for cathodic reduction those cation with more negative half cell potential E0 half cell value and less reduced are less reduced. So in competition with H plus, lithium plus, sodium plus, calcium plus 2, Na plus 2, magnesium plus 2, Al plus 3, Zn plus 3, or Pb plus, or Fe, or nickel, or tin are not reduced. When these ions, which I have just spoken, if they are present in competition with H plus will be reduced. These ions will not be reduced. This is the rule that we need to understand. And hydrogen gas is released, but if elements like copper, mercury, silver, gold, platinum are present, then these copper, mercury, gold, silver, or platinum are reduced and H plus will not be reduced. Same way, if we look at the anodic oxidation, fluorine, chlorine, bromine, if fluorine, chlorine, bromine are present, then OH minus are not oxidized. But if CO3 minus 2, SO4 minus 2, or NO3 minus are present, then OH minus are oxidized and these are not oxidized. So, for example, if we pass DC current through the dilute aqueous solution of H2SO4, you know H2SO4 has 2H plus and SO4 minus 2 ions. So it will, and if it is aqueous, then H plus and OH minus ions are also present. So it has H plus, SO4 minus 2 and OH minus ion present into aqueous solution of H2SO4. This is what we understand. Now in this solution, what happens? At anode, instead of SO4 minus 2, OH minus ions are reduced, and at cathode 2H plus will get 2 electron and we get H2Os. We get OH minus ions that is converted into water, oxygen and 4 electron. And this is how electrolysis of your dilute H2SO4 solution is nothing but the electrolysis of water. Even during the electrolysis of water, we studied in 10th standard, we add some H2SO4 so that the electricity can be easily passed. Now we'll look at the next But if electricity is passed through the concentrated H2SO4 solution, now we'll need to understand what happens if electricity is passed through the concentrated H2SO4 solution. When we pass the electricity through the concentrated H2SO solution, instead of OH minus ion, these SO4 minus 2 ions are converted to S2OH minus 2 ions and 2 electrons. And at cathode, hydrogen gas is produced. Now here we need to understand one more term which is known as the inert electrode. Those electrodes which do not take part in the process of electrolysis are called inert electrode. For example, if you have platinum electrode or if you have graphite or carbon electrode, they generally behave as an inert electrode. Now we'll go. It is interesting to note that the order of reduction at cathode is, platinum will be reduced, then gold, then silver, then mercury, then copper, and then hydrogen. So if these ions are present, hydrogen will not be reduced. But if these ions are present with hydrogen, hydrogen will be reduced. Then Pb, then tin, then nickel, then iron, chromium, zinc, aluminum, magnesium, sodium, calcium, potassium, and lithium. This is all it is because of the E0 half cell. Same way, if there is a mixture of Na3Lf6, CaF2, and Al2O3, according to this, like Na, then you have aluminium, then you have calcium. So sodium, calcium, and aluminium. We know that aluminium will be reduced as compared to sodium and calcium. So this is how aluminium is obtained in a pure way by the method known as the Hall-Héroult method that we will study later. According to the above order on electrolysis, aluminium will be reduced even both sodium plus and Ca plus 2 ions are present. The molten mixture in the molten mixture. Same way for anion we can say that I minus is greater than Br minus is greater than Cl minus is greater than OH minus is greater than NO3 minus is greater than SO4 minus 2. That means SO4 minus 2 will be reduced at last. So if OH minus is present and Cl minus is present, Cl minus will be oxidized. If OH minus is present and Br minus present, Br minus will be oxidized. If OH minus is present and I minus is present, I minus will be oxidized. If I minus and Br minus present, I minus will be oxidized. If NO3 minus and OH minus are present, OH minus will be oxidized. This is how you can simply understand it. Now there is an exception. This is the exception that we have already studied into the 11th standard. When mercury is used as a cathode, sodium plus ions are reduced preferentially in comparison with H plus. So this is only for the sodium ions, that is in the presence of the mercury electrode. Instead of H plus ions, sodium plus ions are reduced. So that is what we have seen in the Kastner-Kellner cell. Mercury cathode and graphite anode is used, and there you will find during the electrolysis into the Kastner-Kellner concentrated sulfuric acid, even though there is even now we'll study the next point. During the electrolysis of concentrated sulfuric acid, even that is the second kind of exception that we need to study. During the electrolysis of the concentrated sulfuric acid, even though there is a presence of OH minus ion, SO4 minus 2 ions are preferentially oxidized into S2OH minus 2 ions. So these two are the exception that we need to remember, and we will have to use them whenever it is needed. Now there is a question: predict the product. So this question we will study into the next video. Thank you, my dear student.